So find the domain of the rational function. So this is a rational function. So remember, to find the domain, we never want 0 in the denominator. So whatever over 0. You never want 0 in the denominator. Okay? So no 0 in denominator. So we have a variable in the denominator. So let's figure out what would make the denominator equal 0, and we're going to exclude that from the domain. So we're going to take our denominator, which is x minus 7, and set it equal to 0 to figure out what would make the denominator equal 0. And so x equals 7. So if we were to plug in 7 into our denominator, we would get 0 in the bottom, and that's a no-no. So for set builder notation, this says all values of x such that x is a real number and x does not equal, basically we do not want x equal to 7, because if it equals 7, that would be undefined. And now for interval notation, for me, I think it's easier to draw a number line first to kind of get an idea of how it would look in terms of all the real numbers, and then graph that, and then convert that to interval notation. So right now, basically, this is saying that x is all real numbers, everything on this number line, except at 7. So let's mark 7. Let's say 7 is there. We're not including 7, so we're going to use an open circle to represent that we do not want to include 7, but it's all the real numbers except 7. So it's everything over here and everything back there. Okay? So let's write what that means. So on this side of the number line, that's negative infinity. And on the right side of the number line, that's positive infinity. And you always want to write your interval from left to right. So starting from the left, we're starting with negative infinity. You always use a parentheses by infinity, comma, all the way to 7. We are not including 7, so we're going to use parentheses. And then we have another interval, which is the right side of 7. So we're going to say union. Okay, go away, please. 7 with the parentheses, because we're still not including 7, comma, positive infinity, and then parentheses. So this is interval notation, and then we already wrote set builder notation at the top. All right. Okay, evaluate the rational equation for the given value. F of x equals x minus 1 over 8x plus 3, and we want to find f of 4. So all that means is we're going to plug in 4 everywhere we see x. So f of 4 would mean that everywhere we see x, there's an x, and there's an x, we're going to plug in 4. So we have 4 minus 1 over 8 times 4 plus 3. And so 4 minus 1 is 3 over 8 times 4 is 32. And we have plus 3. So then we're going to continue to simplify the bottom. 3 over 32 plus 3 is 35. And then for the question here, it says to write your answer as a reduced fraction or an integer. And we can't reduce this fraction further, so this will be our final answer, 3 over 35. Question 3, simplify the rational expression. So let's see what we've got. So right now, we can factor the bottom. So let's factor out a GCF from the bottom, which the GCF of the denominator is 5 here. So we'll factor out 5, and then we're left with x minus 3. And at the top, let's just rewrite what we have, 3 minus x. So if you look at it, we almost have something to cancel out. It's close. We have an x here and an x up there and a 3 up here and a negative 3 down here. But right now, we can't cancel anything out. So in this situation, we want to factor out negative 1 from the top, okay? Or just a negative, either way. So let's factor out negative 1 at the top. And what that is basically going to do is going to change our signs at the top. Because if we factor out a negative 1 from 3, we'll have negative 3. And if we factor out negative 1 from negative x, we have positive x. And remember, when you're factoring something out, you're doing the reverse of distributive property. So remember that negative 1 times negative 3 is positive 3. And negative 1 times x is negative x. So by factoring out that negative 1, we just did reverse distributive property. And then I'm going to just rewrite the bottom, 5 times x minus 3. And if you notice at the top, we do now have the same factor going on. We have negative 3 at the top, negative 3 in the bottom, x at the top, and x at the bottom. And if you want to rewrite it so it looks the same, you can do that. This is a positive x, and that's a negative 3 over 5 times x minus 3. So now you see that your x minus 3 factors do cancel out. And then all you're left with is negative 1 over 5. And that's our final answer. Okay, question 4. Divide the rational expression. So we want to factor everywhere possible after doing what I call keep, change, flip. So when we divide by any rational expression, we're going to use keep, change, flip. That's a short way of saying multiply by the reciprocal. So that means that we're going to keep the first rational expression the same. We're going to change division to multiplication and then flip the second rational expression. So it's going to be y squared minus 14y plus 48 at the top, and then y squared minus 6y minus 16 at the bottom. All right, so now we've got some factoring to do. So let's see, at the numerator in the first rational expression, we have a GCF of y, so I'm going to factor that out, and then I'll have y squared plus 6, and then at the bottom I have a GCF. No, I don't have a GCF, but I do have difference of 2 squares. So this is the same thing as y squared minus 6 squared. So then that would be y plus 6 times y minus 6 times. Now let's factor the second rational expression. So we have a trinomial. So the way I factor trinomials, I first look at the leading coefficient. It's a 1. So I'm going to go ahead and set up my binomials, y and y. Now, let's look at the 48. So at first, we can get my signs together. So I like to use the sign rules when I factor trinomials. So we always look at that first sign, which is negative 14. I just keep that sign, bring that sign down, and then to get the next sign in the factors, I multiply the negative and the positive in my trinomial. Negative times positive is negative. So this is also going to be negative. And because I use the sign rules, when I get my factors that need to go into the binomials here, I always put the larger factor first. So I need 2 numbers that multiply to give me 48 and are going to add, because 48 is positive, to give me 14. And so that would be 8 and 6, because 8 times 6 is 48 and 8 plus 6 is 14. So I have 8 and 6. So now I'm going to factor the bottom. So I'm going to set up my binomials. The leading coefficient is a 1, so I can go ahead and start off with y and y. And so let's take my signs. The first sign is negative, so I'm going to bring that here. And then I'm going to multiply the signs in the trinomial to get the second sign. So negative times negative is positive. That's my second sign. So now I need two numbers that multiply to give me 16, but subtract because it's a negative 16 to give me 6. So those two numbers would be 8 and 6. 8 and 2. 8 and 2. Because 8 times 2 is 16, but 8 minus 2 is 6. And remember, I always put the larger factor first, so I have 8 and 2. And so now I've factored everything, and so now it's time to cancel out any common factors at the numerator and the denominator. So let's see, I've got y minus 8 cancels out, and I have y minus 6, and y minus 6 cancels out. And that actually is all the canceling I can do. You may want to cancel something with the y plus 6 in the bottom and the y squared plus 6 at the top, but those are not the same factors. So we cannot cancel those out, and there's no single y at the bottom to cancel with this y at the top, and there's no y plus 2 to cancel with the y plus 2 in the bottom. So now we're just going to write what we have left, and that's going to be our final answer. So y times y squared plus 6 divided by y plus 6 times y plus 2. And you know, if this was a typo, it would have been really neat if this started off with y squared plus 6y, because then this would be just y plus 6 and we could cancel some more. But it's not, so this is going to be our final answer here. Okay, question 5. Perform the indicated operation to simplify the rational expression. So in order to add and subtract rational expressions, the same thing as fractions, you must have a common denominator. The denominator must be the same, which in this case they are x minus 3, x minus 3, x minus 3. So if they have the same common denominator, you just keep that denominator and then combine the top. So the top, we have x squared minus 7x plus 12. And then now to simplify it, we have to factor the numerator and see if we can cancel anything out. So look at the leading coefficient. It is a 1, so I can go ahead and set up my binomials. I'm going to take the first sign here, which is negative, so that's the first sign in my first binomial, and then to get the next sign in my second binomial, I multiply these two signs. Negative times positive is negative. So there we go. And now I need two numbers that will multiply to give me 12 and add, because 12 is positive, to get me 7. So those two numbers would be 4 and 3. So I'm going to put 4 and 3. In this case, it wouldn't have mattered where I put the 4 and 3 because they're both going to be negative, but just to be consistent, I always put the larger factor first because it does matter when I have different signs in my binomials. So now I have x minus 3 at the bottom, and then now I can see x minus 3's are going to cancel. So then all I'm left with for my answer is x minus 4. That's my final answer there. Okay, question 6. So now we're subtracting, so pay attention to what operation you're doing. But we don't have common denominators right now. And there's no way to know what the common denominator should be without factoring the denominators to see what all you need to include in your greatest common denominator, or greatest common factor, least common denominator, sorry. You need a least common denominator, so we need to factor to figure out what factors we need to consider. So I'm going to just rewrite them here. So x over, let's factor the first denominator. This is the difference of two squares. This is the same thing as x squared minus 4 squared. So that would be x plus 4 times x minus 4 for that denominator, minus 3 over, now we need to factor this trinomial. So the leading coefficient is a 1, so I can set up my binomials. The first sign is positive, and then multiply the signs to get the next sign, which would also be positive. And I need two numbers that will multiply to give me 4 and add to give me 5. So that would be 4 and 1. So now we need a least common denominator. So the least common denominator needs to include all of the factors in all of the denominators. So pay attention. So let's see, the first rational expression has an x plus 4. That needs to be in there. It also has an x minus 4. The second denominator has an x plus 4. We've already taken care of that. But it also has an x plus 1. So your least common denominator would be this entire expression, x plus 4 times x minus 4 times x plus 1. So what you want to do is multiply both expressions by that LCD, and what will happen is that you will cancel out the denominators and then you can simplify from there. So basically I'm multiplying all of this by that LCD, and then this one by my LCD. So let's see what happens. Let's see, x plus 4 is cancel, x minus 4 is cancel, and so at the top I'm just going to have x times x plus 1. Okay, and now over here, the second rational expression, you see the x plus 4 is cancel, the x plus 1 is cancel, and then all I have left is minus 3 times x minus 4. So now let's just distribute. X times x is x squared, x times 1 is x, negative 3 times x is negative 3x, and negative 3 times negative 4 is positive 12. And then we're going to combine like terms, which would be here. X minus 3x is negative 2x. And then we'll just bring down our x squared plus 12. And we don't have to factor, we're just trying to simplify. And this actually wouldn't be factorable. So this is our final answer here. X squared minus 2x plus 12. Question 7. Simplify the complex fraction. Spell error. That's why I'm a math teacher, right? Fraction. Okay, so least common denominator. So there's a few, you could actually use a couple of ways, but I think the most direct way would be to get the least common denominator for the entire fraction and then multiply everything by that. The numerator here, we have a 1 minus 6 over x. So the denominator for the 1 is just 1, and then we have a denominator of x. So right now we need to definitely include x in our least common denominator. And if we look at the denominator here, we have x minus 36 over x. The denominator here at the bottom is just x. So our LCD is simply x. So we're going to multiply the top by x and the bottom by x. So when we do that, x times 1 is x, and then we have minus 6 over x times x divided by x times x minus 36 over x times x. Okay, so now let's see what's going to happen. So 1 times x is just x. And then negative 6 over x times x, your x's cancel out, and I'm just going to have minus 6. So that's my numerator. And then at the bottom, x times x is x squared, and then negative 36 over x times x, the x's cancel out, and I'm left with just negative 36. And then now I can factor the bottom, that's the difference of two squares. I'm going to have x plus 6 times x minus 6. And then I'm going to cancel out common factors, which would be x minus 6 and x minus 6. At the top now I'm going to have just a 1, because when I cancel out, what's happening is x minus 6 divided by x minus 6 equals 1. So that's why we're left with just 1 at the top. And on the bottom, we just have x plus 6. So that's our final answer here. solve the rational equation and check your solutions. So check for extraneous solutions. So again, it's another problem where we want to multiply by the least common denominator. So we have x and 8. So if we multiply those together, our LCD would be 8x. So we want to multiply everything by 8x. So we'll have 8x times 8 over x plus 8x times 7 over 8 equals, don't forget to multiply here, 8x times 1. So let's see what's going to happen. X divided by x is 1, so we're just left with 8 times 8. 8 divided by 8 is 1, so we're just left with plus x times 7 is 7x equals 8x times 1 is just 8x. 8 times 8 is 64 plus 7x equals 8x. Subtract 7x because we're solving the equation. So we have 64 equals 1x. So that means that x equals 64. And so if we go back and check our equation, you want to go and make sure if you're to plug in 64 into your equation, you wouldn't get something undefined. And we wouldn't. If we plug in 64 in for x, we would be left with 8 over 64, which is completely fine. And you can also actually check your answer by actually plugging it in if you want. So we're going to plug in 64 in for x. So that would be 8 over 64 plus 7 over 8 equals 1. And you can actually put that in your calculator if you want. 8 divided by 64 plus 7 divided by 8. And you will get 1. So 1 equals 1. That's correct. So we have verified that our answer is correct. Question 9. Solve the rational equation and check your solutions. So we have m minus 10 over m equals 9. Let's multiply by the least common denominator, which would be m. Because this first expression, m, that has a denominator of 1. And then the denominator for the second expression is m. And the denominator for the 9 is just a 1. So 1 times m is just m. So we're going to multiply everything by m. Okay, so m times m minus m times 10 over m, we distribute there, equals 9 times m. M times m is m squared. M times 10 over m, the m's will cancel out to 1, so we'll have minus 10 equals 9m. So we have m squared here, so we actually have a quadratic. So we need to move everything to one side and set it equal to 0, factor and solve. So I'm going to subtract 9m. It's going to be m squared. I'm going to write minus 9m before the negative 10, so I can put it in standard form, equals 0. So I have a trinomial to factor. So I'm going to set up my binomials. My leading coefficient is a 1. So I can bring down my m and m. Let me do my sign rules. Bring down the first sign, which is negative, and then multiply these signs to get the next sign in the binomials. Negative times negative is a positive. So I need two numbers that will multiply to give me 10 and subtract, because 10 is negative, to give me 9. So that'll be 10 and 1. And so I want to put the larger factor first. So it's going to be 10 and 1. And so remember, I'm trying to solve this. So in order to solve this, I'm going to use the zero product property, which basically means I'm going to set each factor equal to 0 and solve. So m minus 10 equals 0. So if I add 10 to both sides, I have m equals positive 10. And then m plus 1 equals 0. If I subtract 1, m equals negative 1. That's my other solution. And then you want to check your solutions. So we got to go back and make sure if I were to plug in 10 in for m, I wouldn't get an undefined answer. And make sure if I plug in -1 in for m, I wouldn't get an undefined answer. So we can check that. So I can plug in the first one. So 10 minus 10 over 10 equals 9. So that'd be 10 minus 1 equals 9, and that's true. Let's plug in -1 in for m. -1 minus 10 divided by -1 equals 9. So -10 divided by -1 is +10. Bring down my -1 equals 9. And -1 plus 10 is 9, so that checks as well. So these are our solutions, 10 and -1. Question 10, solve the literal equation for the specified variable. So h equals 2a divided by capital B plus small b. So let's see, and we're solving for b. All right, so first let's get this out of a rational expression. So let's multiply both sides by b plus b, big B plus little b. So big B plus little b times h equals big B plus little b times 2a. So we multiply both sides by b plus b over b plus b. There we go. All right, so now let's see what happens. So on the left, let's just distribute the h. So we have big B times h plus little b times h equals b plus b cancels with b plus b. So I just have 2a equals 2a. I'm solving for big B, so let me move this plus bh to the other side, the small bh, minus bh, minus bh. That cancels out, and I have big B times h equals 2a minus little b times h. And then again, I'm solving for big B, so we're going to divide by little h, divide by little h. So that will cancel out, and all I will have left is big B. Then I have big B equals 2a minus little b times h divided by little h. And that is my final answer. You don't have to split this up. You could if you wanted to. It's not required, but you could do 2a over h minus bh over h, and then you could see those h's cancel and say that's 2a over h minus b. You could do that, but this form is fine as well. Question 11. Anthony and Carmen both work for Smith Landscaping Company. Anthony can finish a planting job in 3 hours, while it takes Carmen 5 hours to finish the same job. How long will it take for them to complete the job if they were working together? So the way that I answer this, I set it up like this. And I'll tell you, you can do this every time. This is a pretty consistent way of solving these type of work problems. So let's start with Anthony. So Anthony can finish planning a job in 3 hours. So let's just assume that he can do 1/3 of the job in 1 hour. And then plus, Carmen takes 5 hours to do the same job. So we can say that it would take her an hour to do 1/5 of the job. And we want to know how long it will take them to do it together. So we'll say equals 1 over t for time. And I also think of time as t equals together, but t really means time here. Okay, so then we're just going to solve this rational equation. We're going to multiply by the least common denominator. So we have a 3, 5, and a t. So 3 times 5 times t is going to give me my least common denominator, which is 15t. So now we're going to multiply everything here by the least common denominator. So let's multiply 15t, everything here, 15t, everything there. So now let's distribute. So 15t times 1 over 3 plus 15t times 1 over 5 equals 15t times 1 over t. So 15t times 1/3, if we look, 15 divided by 3, 3 goes into 15 5 times, 3 goes into 3 1 time. So now we just have 5t times 1, so that's just 5t. All right, so now let's see, 15t times 1 over 5, 5 goes into 15 3 times, 5 goes into 5 1 time. So I have 3 times t times 1, so that's just going to be 3t equals 15t times 1 over t. T divided by t cancels out to 1. So I just have 15 times 1, which is 15. So 5t plus 3t is 8t equals 15. And then we would divide both sides by 8 to solve for t. So t equals 15 divided by 8. So the exact answer as a fraction would be 15 over 8 hours. Now then it says it will take them about blank hours to complete the job if they're working together. Let's divide 15 divided by 8. You can use your calculator. That ends up being approximately, well actually exactly, 1.875. So we can round that to about 2 hours. But the way we set this up by saying 1/3 plus 1/5 equals 1 over t, that's a consistent way of solving these. So if this was Anthony was planning a job in 8 hours, it takes him 8 hours, Carmen takes her 2 hours, how long will it take them to do it together? You would just change the numbers here. But this is a very consistent way of solving problems like this. Okay, so on a map, the length of a nature-centered trail is 9.1 centimeters. If the scale is 1 centimeter to 25 kilometers, what is the actual length of the trail? Round the nearest tenth, if necessary. So we're trying to convert centimeters on this map into kilometers. And the way we're going to do that is we're going to use this scale here. 1 centimeter equals 25 kilometers. So 1 centimeter equals 25 kilometers. So we have 9.1 centimeters, right? And we're going to use a proportion to solve this. So we want to figure out 9.1 centimeters is proportional to x kilometers. And that's what we're solving for. The actual length of the trail, that's going to be this, okay? And that's proportional to the scale. So the scale says that 1 centimeter is the same as 25 kilometers. And so when we're doing proportions, since we have centimeters at the top, we need to have centimeters at the top in your ratio here. And then we need to have kilometers at the bottom so that they're in the same order, okay? So now our scale, we're using that here, is 1 centimeter is proportional to 25 kilometers. And so now we have a rational equation to solve. So we can just cross multiply. So we have 9.1 times 25 equals x times 1. So basically 9.1 times 25 equals x, which is what we're trying to find. And you can use your calculator to do 9.1 times 25, and you would get 227.5 equals x. And it says round to the nearest tenth, and that's actually the entire answer. And we're going to use our proper units. This is going to be 227.5 kilometers. Question 13. Simplify the radical expression. So we have the fourth root of negative 16. So remember, when we have even roots, so that's square root, fourth roots, sixth roots, and so forth, you never want negatives or negative radicands. Let me say it that way. We never want negative in the radical. So if that happens, that means it's no real, I can't talk. That means it's imaginary or no real numbers or undefined. Okay? So if this ever happens, that means that it is undefined. Imaginary numbers, which we're not talking about yet, but we will after this test. No real numbers. And that's what we have here. The fourth root of negative 16 is not, it is not negative 2. Okay? This does not equal negative 2. And you may ask, why is that? That's because, remember, this means that, so the fourth root of 16 is positive 2. And then why? Because 2 to the fourth equals 16. But if we take the fourth root of negative 16, the fourth root of negative 16 does not equal negative 2. Because think about it. Negative 2 to the fourth power is negative 2 times negative 2 times negative 2 times negative 2. This is going to give us positive 16, not negative 16. So that is why this does not work. Okay? So if you ever have a negative under an even root, you just automatically say that is no real numbers. Okay? And then we're going to learn after this test, I think 5.6 maybe? It's all a blur. We're going to learn about what imaginary numbers. This actually is going to give you an imaginary number. That's why we say it's no real numbers, because it's imaginary. We're going to throw in a letter I, and we'll talk about that later. So don't you worry yourself now. That'll be after your test this week. Okay? So the answer here is undefined, no real numbers. And I want to say on the actual test, if this happens, if your answer is no real numbers, you have to type NRN, which means no real numbers in the Blackboard test. And it'll tell you that. It'll remind you if it's no real numbers, type NRN. So that's another reason to do your review several times, because you'll get used to the questions and used to how they're asking them. Question 14, convert the number to scientific notation. So we have 72,000. So based on this number here, your decimal technically would be right here. 72,010 cents, or point whatever. Your decimal is here. So scientific notation, you want to be in this form. A number between 1 and 10 times 10 to some exponent. Okay? And the way you figure out what goes here is you're going to move the decimal however many times you need to create a number between 1 and 10. So, for example, if we were to move the decimal just 1, 2, 3 times, you would end up with 72.0. That's not between 1 and 10. If we move it 1, 2, 3, 4 times, we end up with 7.2. That is between 1 and 10. So 7.2 will be the number that goes here. Times 10 to the what power? We move the decimal 1, 2, 3, 4 times. That'll be 10 to the 4th power. If this was a small, no, this is a very large number, 72,000. So that's why your exponent is a positive exponent. It makes 7.2 times 10 to the 4th, 7.2 times a big number. If this was like 0.00000 something, then your exponent would need to be negative, because that's a very, very small number. But your final answer here is just 7.2 times 10 to the 4th power. Okay, that's how you convert to scientific notation. Question 15. Use radical notation to evaluate the expression and simplify if possible. So we have negative 27 raised to the 4 thirds. If you're using your graphing calculator, yes, you can put this in the graphing calculator and get your simplified answer. You can do that. I also want to show you how you would rewrite it into radical notation to evaluate it. So I'm going to write it a little bigger. Negative 27 to the 4/3. So the way that I remember this, so the 3 is your root number, and the 4 is your power. And then the negative 27 is the radicand that goes underneath the radical sign. So it's going to be the 3rd root of negative 27 raised to the 4th power. That's how we change this rational exponent notation into radical notation. So now we're going to evaluate it. So we'll work within the parentheses and find the 3rd root of negative 27. The 3rd root is an odd root, so you can have the odd root of a negative number. So that's going to be negative 3. And you can put this in your graphing calculator as well. Or you can think, okay, 3 to the 3rd power is 27. So negative 3 to the 3rd power is negative 27. Negative 3, and then we have to the 4th power. And then we want to find negative 3 to the 4th power is going to give us positive 81. But you could put negative 27 in parentheses, raised to open parentheses 4 divided by 3, and you will also get to your 81. Okay? So you can use your calculator for this problem, but you also want to know how to convert it into radical notation to answer the problem. 16. Multiply and then simplify the radical expression if possible. So we have a binomial times a binomial. The first binomial is the square root of 12 plus 3 times the square root of 12 minus 3. So for a binomial times a binomial, we're going to use distributive property. And the fun way we do that with binomials is to FOIL. So that means we're going to multiply the first terms in the binomials, multiply the outer terms, multiply the inner terms, and then multiply the last terms. So we have square root of 12 times the square root of 12. I'm just going to write it all out. And then we have minus 3 times the square root of 12 plus 3 times the square root of 12 minus 3 times 3. So the square root of 12 times the square root of 12, they both are square roots, so we can do the square root of 12 times 12. Negative 3 square root of 12 plus 3 square root of 12, they are like radicals, and they will equal 0. And then negative 3 times 3 is negative 9. So then we have the square root of 144 minus 9. The square root of 144 is 12 minus 9, which equals 3. Rationalize the denominator and simplify. So for problems like this, we're going to multiply the top and bottom by the conjugate. This is how you get the conjugate. So if it starts off as a plus the square root of b, the conjugate would be a minus the square root of b. We have 8 minus the square root of 6 in the bottom. And again, rationalize denominator means we do not want a square root in the bottom. So we're going to multiply the top and bottom by the conjugate, and that's going to help us get rid of that. And so again, if it was a minus the square root of b, the conjugate would be a plus the square root of b. So just change the sign. That will give you the conjugate. So here we're going to multiply the top and bottom by 8 plus square root of 6. 8 plus square root of 6. So I have 3 over 8 minus square root of 6 times 8 plus square root of 6 over 8 plus square root of 6. That's going to be 3 times 8 plus the square root of 6 Put that in parentheses, so we multiply the 3 by both terms. And now on the bottom, I'm going to FOIL. So we have first 8 times 8, outer 8 times the square root of 6, inner negative 8 times the square root of 6, and then last negative square root of 6 times the square root of 6. So see the top part, we'll go ahead and distribute. 3 times 8 is 24. 3 times the square root of 6 is 3 square root of 6 over 8 times 8 is 64. 8 root 6 minus 8 root 6 cancels to no root 6, so it's 0. And then we have minus the square root of 36. So now we have 24 plus 3 root 6 over, this is going to be 64 minus 6, okay, because the square root of 36 is 6. 64 minus 6 is 58. And then now here we want to see if we can reduce this, okay? So what that means is you want to see if 24, 3, and 58 have a common factor. And it turns out they don't. The 3 is throwing it off. So 24 and 58 definitely have some common factors. They're both even. 3 is not even. And then 3 is not a factor of 58. And I wasn't sure. So I divided in my calculator. And 58 divided by 3 is 19.333. So there is no common factor. So the final answer is just going to be what you see here. 24 plus 3 root 6 over 58. That's your final answer. But you always want to check and see. The simplified part means to see if you could simplify these all with a common factor. So for example, like if this 3 was a 2, then you could factor or reduce them all by dividing by 2. So you can kind of like reduce the fraction. But they don't have a common factor, so that's why this was our final answer still. Okay, question 18. Solve the radical equation and check your solutions. So we want to get this square root by itself. So let's start by subtracting 8. So I have the square root of x plus 48 equals x minus 8. So now to get rid of that square root, I'm going to square it. But if I square the left side, I must square the right side of the equal sign. So on the left, I have x plus 48 because the square root and the square cancel out. On the right, I have x minus 8 squared. Now, in order to multiply this out, I'm going to write it twice and FOIL. So if I FOIL this, that's going to be x times x, which is x squared, minus x times 8, negative 8, which is negative 8x. Negative 8 times x is negative 8x. And negative 8 times negative 8 is positive 64. So I'm going to bring down that x plus 48 so I'm ready to deal with it. So now I have negative 8x minus ax is negative 16x. I'm going to bring down the rest of my right side of the equation, write down the left. And now I have an x squared here, so it's a trinomial. Well, maybe not a trinomial, but it's a quadratic. So I want to set it all equal to 0 to start solving this. So that means let me move the x and the 48. Because if it is a trinomial, I want this x squared to stay positive. So when I factor it, it's much easier to factor. If I were to move this x squared to the left, I'd have a negative x squared, and that would just make things more difficult. So I'm going to subtract x and subtract 48. So now I have 0 equals x squared minus 17x, and then 64 minus 48 is 16. So now I need to factor. I'm going to set it up. X and x equals 0. A leading coefficient is a 1, which is great. Those are easier to factor. So I have x and x. My first sign is a negative. That's going to be my first sign in the binomial. And I'm going to multiply the signs in the trinomial to get the next sign. That's going to also be negative. So I need two numbers that will multiply to give me 16 and add, because 16 is positive, to give me 17. So that's 16 and 1. And I'm solving. So that means I need to take each factor and set it equal to this 0. So x minus 16 equals 0. X minus 1 equals 0. So when I solve for x equals positive 16, and x equals positive 1. And then I need to check my solutions. I need to go back and make sure that if I plug in each of my solutions, I don't get something extraneous. So let's do that. So let's try the 16. That's going to be the square root of 16 plus 48 plus 8 equals 16. So 16 plus 48 is 64. So the square root of 64 plus 8 equals 16. The square root of 64 is 8. 8 plus 8 is 16, so I'm good there. Let's check the 1. The square root of 1 plus 48 plus 8 equals 1. So the square root of 1 plus 48 is the square root of 49 plus 8 equals 1. The square root of 49 is 7 plus 8 equals 1. 15 equals 1. Not true. So we're going to not include x equals 1. That's an extraneous solution. So the only one that we want is x equals 16, because x equals 1 gives you an extraneous solution based on what we checked here. So you're always going to check your solution when they ask you to check your solution. It's really good to check all your solutions, but if they're telling you to check it, that's a huge sign. It's a possibility of having an extraneous solution. Let's look at 19. Abigail needs to determine the distance at certain points across a lake. She and her crew are able to measure the distances shown on the diagram below. Find how wide the lake is to the nearest tenth of a meter. So this is a special type of triangle we have here. That's a right triangle. And the reason why we know that is because of this guy right here. That's the symbol for a right angle. So it's a triangle with a 90-degree angle. So we use a special theorem called Pythagorean theorem. And that is a squared plus b squared equals c squared. So a and b are the legs of your triangle, and c is called your hypotenuse. So what does that mean? So if you have a right triangle, here's the right angle. The hypotenuse is always opposite of the right angle, and the legs can be either, it's the other sides. Okay. So for this one, we know the hypotenuse here is 130 meters because it's opposite of the right angle. All right. And then the legs, we know one leg is 60. And the other leg we don't know, and that's going to tell us how wide the lake is. So we'll say that's x. So we'll say x squared plus 60 squared equals 130 squared. In our calculator, 60 squared is going to be 3,600 equals 130 squared is 16900 or 16,900. And bring down your x squared. To solve for x squared, we're going to subtract 3,600 from both sides. So we're going to have x squared equals 13,300. And then it's x squared. So to solve for x, we're going to take the square root of both sides. So we have x equals whatever the square root of 13,300 is. And we're going to use our calculator to find that answer. And so we end up with 115.325659. But it says, how wide is the lake? To the nearest tenth of a meter. And our units are in meters, so we're good. So we got to round that to the nearest tenth. So we're rounding this 3. So we look to the right, that's a 2, so that means we're going to keep that 3 the same. So it's about 115.3 meters. But you do want to remember Pythagorean theorem. That is a very important formula for right triangles, only for right triangles. And remember that C is your hypotenuse, A and B are your legs. And the hypotenuse is always opposite of the right angle. I'm going to use the factor tree to reduce the third root of 375. So I'm going to start with two numbers that multiply to give me 375, and that was, I used 25 and 15. And I'm going to continue with my factor tree until I have nothing but prime factors, which would be this, 5 times 5 times 5 times 3. It's the third root, so I'm looking for groups of 3 of the same factors. So there we go. So I'm going to write that on the outside, and whatever is left over, which is this 3 in this case, would stay under the radical. And I'm going to leave this y to the fourth here, because I'm going to deal with that in a second. And so now we're going to do the third root of 81. And what I was saying was you can put the third root of 375 in the calculator just to check and see if you get a whole number. And you won't have to do a factor tree if you're not sure if it's a perfect third. But if you put it in the calculator, you get a decimal, that means you're going to have to simplify it in this way. So I'm going to reduce the third root of 81 and use two numbers that multiply to give me 81. And I'm going to continue until I have nothing but prime factors, which I have here. I'm looking for groups of 3 of the same kind because it's a third root. So I have 3 outside the radical, and then inside the radical is what's left over. So I have the third root of 3 inside. And then I had on the outside originally this y, and on the inside this y. And I also had a negative. So just to kind of show you, so basically this came from this, and this came from that. So now I'm going to deal with my variables. So the third root of y to the fourth. The way that I do that is that I think, okay, 3 goes into 4 how many times? 1 time, so that's going to be y to the first, with how many remaining? 1. 3 goes into 4 1 time with 1 remainder. So we're going to have y to the first as a remainder under the radical. Another way you could think about that is the third root of y times y times y times y. Basically writing it as prime factors like we did with the factor tree. We're looking for groups of 3 of the same factors. There's 3 y's, so we're going to write that on the outside, and what is left over goes under the radical. So either way you go, that's how you would reduce that. So that's y times the third root of y. That comes from what we did here in green. And I still have this 5 on the outside. I still have this 3 on the inside. And then now minus the third root of 3y. Well, this y has an exponent of 1, and 3 cannot go into 1. So this is simplified as far as it can go. So I'm just going to rewrite it here. So now we have what's called like radicals. And just to make it clear, I'm going to write it all in black. So that's 5y times the third root of 3y minus 3y times the third root of 3y. So we have like radicals because of this. Okay, they have to have the same root number. They're both root 3. And they have to have the same radicand or expression under the radical, which is both 3y. That's like saying if it was, 5x minus 3x, they're like terms. These are called like radicals. So you would just keep the like radicals there, and then you would combine the outside. 5y minus 3y, which is 2y. So your answer would be 2y times the third root of 3y. So that's your final answer there. Okay, so let me try to find that question that you had. Okay, your problem actually looks like this. It is the square root of m minus 3 plus 3 is out of the radical. You notice that? Equals 6. So that's different. That's different. So what we're going to do is, before we can get rid of the square root, we just subtract the 3. So then now we have the square root of m minus 3 equals 6 minus 3, which is 3. Now you can get rid of the square root by squaring the left and then squaring the right. So on the left, we're going to have m minus 3 equals 3 squared, which of course is 9. So m minus 3 equals 9, and then to solve for m, we're going to add 3. So m equals 12. So you should actually get 12 for your answer there. And you can check it by plugging it back in. So you can say the square root of 12 minus 3 plus 3 equals 6. So the square root of 12 minus 3, 12 minus 3 is 9. So we have the square root of 9 plus 3 equals 6. The square root of 9 is 3 plus 3 equals 6. So 6 equals 6. So it's very different to say the square root of m minus 3 and then plus 3, as opposed to the square root of m minus 3 plus 3, all under the square root. But I'll be around all week, so feel free to email me if you got any questions. And like I just did, I can pull up your exact question. So don't feel like you have to, if you feel intimidated to have to write it out or, explain it, just tell me your name, your CRN, what homework question or what quiz question or what test review question. I can see exactly what you are working on. So good luck, guys. Study hard. We have a small group, but this was a great use of time, and I'm hoping it was helpful. And yeah, also don't hesitate to go to the workshops that I have posted. I'm going to give you guys an extra credit opportunity to attend those knowledge review sessions. I'll post that on Blackboard shortly, but I'm thinking I can replace a homework grade for every session that you are able to go to. So kind of keep that in mind. We'll have some final review sessions coming up in April. But anyway, I hope you guys have a great week, an awesome Monday, and I will talk to you later. Bye.